All right, lesson 8, conditional probability, and the cooldown called soccer games. So we're talking about conditional probability. Now, conditional probability basically means the probability that one event occurs under the condition that another event occurs. For example, let's say we remove 2 marbles from a jar that contains 3 green marbles, 2 blue marbles, 1 white marble, and 1 black marble. We might consider the conditional probability that the second marble we remove is green, given that the first marble removed was green. Since there's only 3 green marbles, if you remove a green marble from the bag, the next time you go to grab a green marble, that changes the probability of grabbing a green marble on the second try. Instead of 3 green marbles, there's only 2 green marbles left out of a total of 2, 4, 5, 6 out of 6. 2 out of 6. What about probability, though, of drawing a black marble, given that the first one was a black marble? This is probably the easiest one to think of. If they pull a black marble first and they keep it out of the bag, how many black marbles are left in the bag? 0. So what's the probability of drawing a black marble given that the first marble pulled from the bag was black? It would be 0. It would be impossible. There is no black marble left to be able to draw from. So since the probability of the second draw changes when you pull a marble out of the bag and keep it out of the bag, we would call that conditional probability. Now there's this equation right here. This is the multiplication rule that relates, oh, and by the way, this terminology right here, that's for conditional probability. This is the probability of A given that B has already happened. So in the marble example, so that'd be like probability of green given that the first draw was a green. That's the way we would write that, where A is what's the probability of drawing a green on your second pull, given that your first one was a green. So the probability, this conditional probability, the probability of A given that B has happened, times just the probability of B gives us the probability of A and B. This relationship right here is always going to be true. And actually, I think that's probably just the most important stuff. The cooldown is much simpler than this. So let's take a look at the cooldown. Soccer games. A soccer team has 2 games in 2 days against different teams. Let A represent the event. The soccer team wins the first game. And B represent the event. The soccer team wins the second game. So describe the meaning of B given A. What's the probability of B if we know that A has happened? And then, do you think A and B are independent events? In talking with students over the last couple of days, I've heard some interesting arguments either way. I think it maybe could possibly go either way, as long as you have a good argument. Make sure you have a good argument for it. If the events are independent, how are this and this related? Well, that might be something I actually missed. Yeah, I did miss that. Sorry. In cases where events A and B are independent, the probability of A given B is just equal to the probability of A. The reason for that is because this right here, the probability of A given that B has happened, if it's the same as just the probability of A, that means that B doesn't affect it at all. It doesn't matter that B happened. Probability of A given B is just the same as probability of A because B doesn't matter. Anyway, if the events are independent, how are probability of B given A and probability of B related? I hope that helps. Let me know if you have any questions.